is Miss Dodson, and I'm a second grade teacher at Lonsdale Elementary School. And I'm so excited today that I have the chance to help you guys do some of your summer work. And you're going to follow along with me in section 3 of your math packet for second grade, and we're going to work on using place value to add and subtract. So if you need any help over the summer, if you or your parent is not understanding something and you guys want to email me and ask me a question, I've got my email listed right there on the screen. Or if you would like to talk to Anstanette, she is awesome. She is our math specialist for pre-kindergarten all the way up through high school, so she'll definitely be able to help you too. Her email address is listed below as well as her Twitter handle. So we're going to get started in just a second, and I should be really good at it because I just did my entire recording and forgot to have the sound on. So I've already done this whole thing once. I'm going to do it again, and it should go really, really well. So our schedule of learning today is we're going to first go over our objectives. So what we're going to be able to do by the end of our video. We're going to review some vocabulary, which is our math words that we need to do all of these fun things. We're going to review some of the skills and strategies that we learned in second grade to add and subtract. And then we're going to solve some examples that either I've made up or that are in your work from home packets. So our objective today is to use place value to add and subtract. So we're going to break this up into two parts. We're going to add and subtract two-digit numbers first using multiple strategies, and then we're going to add and subtract three-digit numbers using multiple strategies. And when I say multiple strategies, I mean all of the things that you learned in second grade. So your teacher probably taught you a bunch of different ways to do math problems, like using models, or breaking apart add-ins, or using an open number line, or forming a hundreds, tens, and ones chart. So I'm going to show you at least one example of all of these different ways, so as you are working through that packet, you have a variety of options to review and to choose from with me. So we're going to do our vocabulary first, and the first thing that we need to do before we get started with actually adding and subtracting is we need to understand the difference between a number and a digit. So a number is the amount of something written with one or many digits, and a digit is a symbol. It's any of these symbols, a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And a number can be written with digits. So here's our example right here. It shows 51. 51 is a number, and it has two digits in it. It has a 5 and it has a 1. So 51 is a two-digit number. The next thing we need to talk about is the difference between the tens place and the ones place. So in a two-digit number, like 86, the left digit shows how many groups of 10 are in a number, and the right digit shows how many ones there are in the number. The number 86 is another two-digit number, just like 51. It's made up of two digits, which are 8 and 6. 8 is in the tens place on the left, and 6 is in the ones place on the right. We just talked about numbers, digits, tens place, ones place, and a really key important part of understanding place value is understanding the value part of that. So we know tens place and ones place, we know the digits that make up a number, but now we need to talk about value. So the numerical value that a digit has based on its position in a number. That sounds a little confusing. So here's what that means. The value of the 8 is 80 because it's in the tens place. That means it's worth 8 tens. So the value of the 8 is not just 8, 1, 2, 3, 4, 5, 6, 7, 8. Because that 8 is located in the tens place, that means that we're talking about 8 tens. So let's put 8 fingers in the air just to make sure. And let's count by tens to make sure that 8 tens is equal to a value of 80. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Counting by tens this time. Here we go. 10, 20, 30, 40, 50, 60, 70, 80. So if you have 8 tens, then you're going to have a value of 80. And that's what that 8 means when it's in the tens place. You're also going to have a value of 6 because the digit 6 is in the ones place, meaning that it's worth 6 ones. Before we add two-digit numbers, let's go over the vocabulary for addition. So when we add, we are bringing two numbers together to make a new greater total. When we put two amounts together, we use this addition sign right here, and a lot of times we use the word plus. So in this example right here, we see that this equation reads 2 fireflies plus 3 fireflies equals a total of 5 fireflies. 1, 2, 3, 4, 5. You have 2, then you add 3 more. You're going to add them together and get 5. Now in our equation, we talked about the addition sign just a second ago, but we also have add-ins. And add-ins is just a fancy way to say the numbers that we're adding together. So in this example right here, this says 9 plus 5. We're adding together 9 and 5, so we're going to call them our add-ins. Then we also have the sum, which is the answer we get after we add something together. That's our answer. It's the answer, it's the same thing as our total, okay? Only for addition though. If we're doing subtraction, you're not going to have a sum. Sum is the answer we get after we add our add-ins together. So the same equation, 9 plus 5 equals 14. That's how much we get when we add 9 and 5 together, and we're going to put our sum right there on the other side of our equal sign. The last term I want to go over with you before we get started actually working out these examples is the term regroup. So in addition, regrouping is the process of changing ones into tens, and we regroup when there are 10 or more ones in the ones place when we add. I'm going to walk you through an example of this because it's been a long time since y'all have been in school and you've had to regroup, and so if it feels a little fuzzy in your brains, that's totally okay and normal. So we're going to get that light bulb to go off and do this example. 38 plus 25. This example uses a base 10 model, meaning that they drew a model using 10 sticks and 1's cubes. So for 38, that's 3 10s, 10, 20, 30, and 8 1s. 1, 2, 3, 4, 5, 6, 7, 8. Then they drew 25. 10, 20, and that 10 stick isn't there just yet, and then 5 1s. 1, 2, 3, 4, 5. When they added, they started at the ones place, which is a good idea when you're using a base 10 model for sure. So when they counted their ones, they got 1, 2, 3, 4, 5, 6, 7, 8 ones, 9, 10, 11, 12, 13. 8 ones plus 5 ones equals a total of 13 ones. And we can't write 13 in the ones place because 13 is not a digit, it is a number. So what we're going to do to fix that is we're going to take 10 of these ones from 13 and we're going to move it over here to the tens place. So these 10 ones just became a 10, and now we only have 1, 2, 3 ones left. So those 3 ones are going to come down and go right there. Now we're going to count the tens. 10, 20, 30 when we first drew it from 38, 40, 50, that's 2 more tens from our 2 tens from when we drew 25, and now we have this extra 10 that came from when we regrouped the ones. So a total of 1, 2, 3, 4, 5, 6 tens, which has a value of 60. So 38 plus 25 equals 63. Just to summarize that all one more time, regrouping is the fancy math word we use for when there are too many ones. And too many ones is anything that's going to be bigger than 9, because 9 is the biggest digit there is. So if you have 10, 11, 40 ones, you would have to regroup some of those to the tens place. So for our first example, we are going to add together two two-digit numbers, 15 plus 37. And the first way I'm going to show you to do this is by using a base 10 model. I'm going to start by writing my equation, 15 plus 37. Now I'm going to draw a tens and ones chart. And here's why I'm doing a tens and ones chart. In my two-digit number, 15 and 37, those are two-digit numbers. They both have 2 digits. They have a tens place and a ones place. So by drawing a tens and ones chart, I'm going to be able to draw a model of both of these numbers and organize my tens all together and organize my ones all together. So after I draw my tens and ones chart, I'm going to draw 15 there, and 15 has one 10, so I'm going to draw one 10 stick, and it has 5 ones. So I drew 5 ones cubes. And since this is addition, I'm going to draw both of my numbers. I drew 15, now I'll draw 37 with 3 10s and 7 ones. Now, drew both numbers because it's addition, and when I add using a base 10 model, I always, every single time, no exceptions, start at the ones place with the base 10 model. That's where I'm going to start to add, because if you have to regroup, it's going to be really hard if you start from a greater place value. So you need to start at the least place value, which is the ones, and then if you have to regroup, it's going to make your life so much easier. So starting at the ones place, I'm going to count my total number of ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, freeze. I didn't finish counting my ones, and that's because as I was counting the ones, I went ahead and got to the number 10. Can I write 10 in the ones place for my sum? I can't because it's not a digit. 10 is bigger than 9, and 9 is the biggest digit. So because I can't fit all of those ones into my answer, I'm going to have to take 10 of these ones, which is why I stopped at 10, and I'm going to have to regroup them over to the tens place. So I'm going to circle those 10 ones, and now they're getting regrouped into a 10 stick. I'm going to cross them out because they're no longer in the ones place. They are now a 10 stick. Now to finish, I'm going to count how many ones I have left, just those 2 down there. And I now, instead of just having the 1 10 from 15, and the 3 10s from 37, I now have that new 10, which I drew right here, because I had to put those 10 ones together. So all together now I have 1, 2, 3, 4, 5 10s, which has a value of 50. So 5 10s and 2 ones is going to give us a sum of 52. Great job. So that's the base 10 model with 2-digit numbers. If at any time you want to pause me, try it on your own, you can rewind me, whatever you need to do to help you do this packet. And this is actually an example from your summer packet. It's in section 3 of your 2nd grade math packet. I showed you the base 10 strategy. Now we're going to talk about breaking apart addends. Let's think about what that means. Remember, addends is the word we use to talk about the numbers we're adding together. So in this equation right here on the screen, you have 2 addends, 15 and 37. We're going to break them apart by their place value right now. So I'm going to draw my equation, write it down, 15 plus 37. And after I'm done writing my equation, I'm going to, this is the signal we used in my class, we have our number right here, break apart addends. So I'm going to break this number apart using place value. I'm going to break it apart into its 10s, break it apart into its 1s, and then we'll add them. So I'm going to break apart 15 right here, breaking apart 10 and 5. Now I'm going to do the same thing with 37, 30 and 7. I'll add my 10s together first. 10 plus 30 equals 40. That could be a fact that you already have in your head. Maybe you just know 10 plus 30 is 40. Maybe you know 1 plus 3 is 4, so you add on a 0. If you don't have that fact in your head, a way that you can figure it out is to skip count by 10s. So if you're starting at 10 and you have to add 3 more 10s, you can go 10, 20, 30, 40. 10 plus 30 equals 40. Now I'll add together my 1s. 5 plus 7 equals 12. Now I'll add together 40 plus 12, and I'll get the same thing I got when I did it as a base 10 model, 52. There it goes, there it stops. So 52, 40 plus 12 equals 52. just like 15 plus 37 from our original equation right here equals 52. I'm going to show you a third strategy that you may use to solve this same problem, 15 plus 37. This is called the open number line strategy. So think about your classroom, and most of our classrooms will have a number line somewhere on the wall. So think about what that number line looks like. It starts usually at a 0 or 1, and as you move, the numbers are going to get greater and greater and greater as they go. Now on a normal number line, it's going to start at 0 and end at a high number. When we use an open number line as a strategy, we get to choose where that number line starts and where it ends. My equation that I'm adding together is 15 plus 37. So when I make this number line, I'm going to start it at 15. I'll draw those arrows at the end because we know that numbers keep on going forever and ever and ever. I'm starting at 15, and now I need to add 37. Now watch how I do this. I'm going to make 3 big hops to show that I'm adding my 3 10s. So 15 plus 10 plus 20 plus 30. Now even though I'm not adding 15 plus 30, I'm adding 15 plus 37, I'm going to break this apart into adding my 10s first and then my 1s. 15 in those 3 hops, 15, 25, 35, 45. I'm going to plot 45 right there. My personal preference when I do an open number line strategy, I don't like to write all those numbers in the middle. I don't like to write 15 and then have to write 25 and then 35 because sometimes our handwriting ends up being a little bit bigger than the line that we drew. And if we have to cram in those numbers, it can make us make a mistake and miscount. So I just like to write the first number I'm starting with and then where I end. So here I was starting with 15. After I added my 10s, I ended at 45. Now I'm going to add my 1s because we're not done yet. We added 30, but we need to add 37. So I'm going to draw 7 little hops. And again, I'm not going to cram my numbers in there. I'm going to go 45, 46, 47, 48, 49, 50, 51, 52. I got 52 when I did the base 10 model strategy. I got 52 when I broke apart my add-ins. And now I have 52 when I did my open number line strategy. You can do an open number line in more than one way though. That's not the only correct way to do an open number line. I'm going to draw my open number line again. I'm going to combine something else that we do in addition that we learned in 2nd grade. We're going to make a 10. So I'll start by plotting my 15 first, and then I'm going to think in my brain, what is the closest 10, meaning the closest number that ends in a 0 that I can get to 15 and get closer to adding 37. So I'm going to think to myself, I'm going to say, well, I know 15 plus 5 makes a 10. It makes 20. So I'll draw 15. I'll show that I'm going over 5 hops. And if I do that, I get to 20. But was my original equation 15 plus 5? No, it was 15 plus 37. But so far, I've added 5 of the 37 I need to add. 37 minus 5 is going to be 32. So I still have 32 that I need to add. So starting at 20, I'm going to do one giant hop to show I'm adding 30. And 20 plus 30 equals 50. Again, you may not know that fact in your head, but you can use strategies to help you. You can say, well, 2 plus 3 is 5, add a 0, and that becomes 50. You can skip count and say 20, 30, 40, 50. 20 plus 30 equals 50, but I'm still not done because so far I've only added 5 and 30, which is 35. But I have to add 37. So I added the 30, I still have 2 more I need to add. So I'll do 2 little hops to show 51, 52. So after watching all of these strategies, after watching me draw a base 10 model and remembering how you've done that, after watching me break apart add-ins, and you might remember doing that one with your teacher, and using the open number line both ways. If you have one that clicked in your brain the best and you thought, oh, I really remember doing this with my teacher and I like doing this in math, then that's the one that you can choose to use as you work your way through your packet. And if you really want to challenge yourself, which I think you should try to use more than one strategy. Let's go ahead and start talking about subtraction, because remember our objective said that we were going to add and subtract two-digit numbers. When we subtract, we're taking away from a number or group of things. When we subtract, the number reduces or becomes smaller. We use a subtraction sign and usually use the word minus as we read a subtraction equation. In this example right here, it shows 4 circles minus 1 circle equals 3 circles. 4 circles, taking away 1, leaves us with 3. I like to think about math, and especially subtraction, as a story. So if you are having a problem remembering, okay, subtraction, what do I do? Is my number going to get bigger or smaller? Think about if I have 4, or if there are 4 dogs at the park, and one of them leaves, and we know that it's leaving because there's that subtraction sign, that means there's only going to be 3 dogs left. When we talked about addition, we talked about how there's a sum, and the sum is the answer that we get when we bring 2 numbers together. We don't use sum when we talk about subtraction. We're going to use the word difference. The difference is the result of subtracting one number from another. Just like the sum is the answer for addition, difference is the answer of a subtraction problem. In this example right here, if we have 9 objects and we're going to take away 4 of them, that's going to leave us with a difference of 5. The last term I want us to go over before we start subtracting our examples is the word regroup. And you might be thinking, Miss Dodson, we already talked about regrouping. We did, but it's different when you're doing subtraction than it is when you're doing addition. In addition, when we had too many ones, we had to put 1 in the tens place. In subtraction, we regroup when there aren't enough ones to subtract. If there aren't enough ones, you have to go next door and get 10 more. Let's look at this example and go through it. The problem is 42 minus 26. In subtraction, you only have to draw your bigger number, your biggest number, if you're doing a base 10 strategy. So you can see whoever did this problem drew 42, 10, 20, 30, 40, and then 2 ones, 1, 2. And again, that 10 stick in the ones place isn't there just yet. So when they started subtracting, because they're doing a base 10 strategy, they started always, no matter what, no exceptions, they started at the ones place. And they said, all right, we've got 2 ones from 42 in my bigger number. Now I need to take away 6 ones. And they said, I'm ready to rock it. And then they went up here and they realized, I only have 2 ones. And if I have 2, I can't take away 6 of them. So they went next door and got 10 more and regrouped that 10 over to the ones place. And they crossed it out here because that 10's no longer with the tens, it's in the ones. Then they were able to take away 6, and after you subtract 12 ones and you take away 6, you're left with 6. And when you subtract 2 more 10s, because this one's already gone, once you take away this 10 and this 10, that would only leave you with 1 10. So your answer would be 42 minus 26. Just to summarize for y'all one more time, regrouping and subtraction is when there are not enough ones to subtract, and then we have to go next door and get 10 more. Just like our regrouping example, we're going to do a base 10 model first to demonstrate how subtraction works. All right, my equation 22 minus 13. And just like with addition in the base 10 model, I'm going to draw a tens and ones chart since both of my numbers have tens and ones. Since this is subtraction, I'm not putting numbers together, I'm taking away from my big number. So I only need to draw my big number, which is 22. 22 has 2 tens and 2 ones. Now I'll start subtracting with my other number, which is 13. And where do we always, no matter what, no exceptions, start when we're doing a base 10 model? we start at the ones place. So in 13, there are 3 ones. So we need to take away 3 ones. But how many do we have? I only have 2. So I can't take away 3 if I only have 2. So I'm going to go next door and get 10 more. I'm going to regroup that 10 stick to the ones place. And I like to unbundle it. That 10 is no longer in the tens place. He's been unbundled and he's now with the ones. Now I can take away 3. 1, 2, 3. When I count to see how many ones I have left, I need to make sure I remember that I don't just count the ones down here. I also need to count the ones that I first had in my model when I drew 22. 1, 2, 3, 4, 5, 6, 7, 8, 9 ones left. But was my problem 22 minus 3? No, it was 22 minus 13. So I still have to take away 10. So I'll cross out that other 10 stick and I don't have any 10s left. So 22 minus 13 equals 9. Let's go on to a different method you can use. If you don't want to use the base 10 model or you want to challenge yourself and do another model, you can use an open number line, the open number line strategy. This time we're going to do a different problem. It says 61 minus 36. My first step is to write my equation again. And I'm going to draw my number line with my arrows. I'm going to make it a little extra long. When we were doing addition, I plotted my first number on the right side, on the left side of my number line. Because as we know about number lines, as you go further and further right, the numbers are going to get bigger and bigger and bigger. And if you go left, the numbers will get smaller. 61 minus 36. I'm starting with 61 and I'm taking away. So are my numbers going to get bigger or smaller? If I'm taking away, they're going to get smaller. So when I plot 61 on my number line, I'm going to plot it on the right side. Because I know I'm going to be working left as I subtract 36. Take away 10, 20, 30, 61, 51, 41, 31. And again, was I subtracting 61 minus 30? Nope, it's 61 minus 36. So I need to subtract 6 ones now. So I'll use little hops to show I'm counting by ones. I'm not going to cram in all those numbers. I'll start at 31 and count back. 30, 29, 28, 27, 26, 25. 61 minus 36 equals 25. That's not the only way you can do your number line. Just like with addition, you can do an open number line and you can make a 10 to help you subtract. I'll start at 61 again, plotting it on the right side, and I'm going to think to my brain, what is the number, the closest 10 to 61? And I've got to remember I'm going backwards. Well, if I only take away 1, I'll still have 60. So 61 minus 1 is 60. But freeze. Was my equation 61 minus 1? Nope, it's 61 minus 36. I've already taken away 1. And now I'm going to think to myself, well, I know that 60 minus 30 is 30. I've taken away 1 and I've taken away 30. So I still have to take away 5 more to get my difference. Starting at 30, I'm going to hop back 5. 30 minus 5 is 25. Either way, if you just want to start your biggest number, do your hops backwards and figure out where you land to get 25, that's a great way to do it. If you want to start at 61 and make 10s to help you go backwards, you can do that as well. You guys have done a great job so far. Do whatever you do in your classroom when you celebrate doing something awesome. Do a dance, kiss your brain, pat yourself on the back, do a seal of approval, or do a fireworks celebration. Whoosh, because you guys have just done some really hard math. And it's been a long time since you were in school, so I know it's not easy. We In our objectives earlier said that we were going to add and subtract 2-digit numbers, which we've done, but we have not added and subtracted 3-digit numbers. That's what we're about to do. I'm going to go ahead before we do examples. We're going to go over the difference between 3-digit numbers and 2-digit numbers to make sure we've got a crystal clear understanding, and then we'll get started working some more examples. In 3-digit numbers, you're going to have ones and tens, but it's different than 2-digit numbers because you're also going to have hundreds. If you were to look at a number line like we were talking about earlier, and you're starting at 0, and then you go 1, 2, 3, 4, 5, all the way to 90, then all the way to 99. 99 is the last 2-digit number. After 99 comes 100, which is the first 3-digit number. In a 2-digit number, we talked about how you have the tens place and the ones place. In a 3-digit number, you're going to have to add that hundreds place. The left digit in a 3-digit number shows how many groups of hundreds are in the number. It's the hundreds place, and the middle digit is the tens place, and the right digit is the ones place. Let's talk about value 2 real quick. If we see this number 486, the value of the 6 is going to just be 6. The value of the 8 is going to be 80 because it's in the tens place. And the value of the 4 is going to be 400 because it's in the hundreds place. One more term to go over before we get started is the word regroup. And you might be thinking, Ms. Dodson, we've talked about regrouping twice now. We did it before we added 2-digit numbers. We did it before we subtracted 2-digit numbers. We need to talk about it again because we are going to have to use it when we add 3-digit numbers, and it looks a little different. In addition, regrouping is the process of changing ones into tens when we have too many ones, but it's also the process of changing tens into hundreds. We can also regroup when there are more than 9 tens in the tens place because 10 tens equals 100. Let's go over this example together. The problem was 368 plus 156. We start at our ones place because they're very smart and they remember to start at the ones when they do a base 10 model. 8 ones plus 6 ones would equal 14 ones. 14 is bigger than 9, so we're going to have to regroup 10 of those ones. So they took 10 of those 14 ones and they made a new 10 stick. They had 4 left. Now they're going to add their tens. Their tens, they had 6 tens, 1, 2, 3, 4, 5, 6, from 368. They had 5 tens right here from 156. They also have a new 10 from regrouping from the ones to the tens. Now, if we have 6, 7, 8, 9, 10, 11, 12 tens, that is way too many. That's more than 9. So we're going to have to take 10 of those tens and put it in the hundreds place. So after I take these 10 tens and make 100, I'm going to have 2 tens left. And then I count my hundreds. 3 plus 1 is 4, plus 1 more is 5. 10 tens and 100. So if you have 10 tens, you get to make 100. We're going to do some examples of adding 3-digit numbers now. We're going to do the base 10 model first, and our 2 3-digit numbers that we're adding are 136 plus 281. When I do a base 10 model this time, I'm not just drawing a tens place and a ones place because my numbers are bigger. They don't just have a tens place and a ones place. They're 3-digit numbers, so they're also going to have that hundreds place. So I'm going to draw an H, a T, and an O. For hundreds, tens, ones. Now I'm adding these numbers, so I need to draw both of my add-ins. 136 has 100, which I'm going to show with a square. It has 3 tens, which I show with 3 10 sticks, and 6 ones, which I show with 6 ones cubes. I'll draw my other add-in now since I'm doing addition. 281 has 2 hundreds, 8 tens, and 1 1. It's a base 10 model. So where am I going to start? At the ones place. Always, always, always. So starting at that ones, I'll count my ones. 1, 2, 3, 4, 5, 6, 7. 6 ones plus 1 1 equals 7. Did I have to regroup there? I didn't, because there wasn't too many. There was less than 9 or less, so I didn't have to regroup. Now I'm going to count my tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. That is way too many. I'm going to have to take 100, so 10 of those tens, and I'm going to have to put them in the hundreds place. So those 10 tens get regrouped to the hundreds, and now I just have 1 10 left, which is only 1 digit, and it shows the value, okay? Let me play this. So we have 1 10 left, which has the value of 10, and 4 hundreds. So 136 plus 281 equals 417. Let's go through that one more time. I drew my model. I didn't have too many ones, so I got to just leave it there at 7. When I counted, I had 11 10 sticks. I can't fit the number 11 right here, so I had to take 10 of those 10 sticks and move them over to the hundreds, leaving me with 1 10 stick that has a value of 10 and 4 hundreds. The next strategy I'm going to show you, which we did with 2-digit numbers, but we're going to do again with 3-digit numbers, is we're going to have our hands up here. This is our number. We're going to break apart our addends. Although I wish I had 3 arms because these are 3-digit numbers now. So really I'm going to have to break apart my addends. The problem we're going to use is the same one, 136 plus 281. And I'm going to use place value and what I know to break them apart into the value of each place. So the value of the 1 in 136 is 100. The value of the 10, or the value of the 3, is 30. The value of the 6 is 6. Same thing with 281. 200, 80, and 1. Now freeze. I made a mistake here. Did anybody catch it? When I was breaking apart those addends, and I meant to write 281, but I only wrote an 8. I'm going to catch my mistake, and making mistakes when you do math is totally okay because math is messy and we learn new things and our brain grows every single time we make a mistake. I'll add together my hundreds first. 100 plus 200 equals 300s. I'm going to add my tens together next, and here's where I realized my mistake. I'm going to say 30 plus 80. Oh, I'm going to add that 0 so it's 80. 30 plus 80 is 110. And 6 plus 1 is 7. Now I'll add those totals down there together. 300 plus 110 plus 7. If I'm adding this and I don't know how to do this all mentally, let's break it down a little bit. I'm adding 7 plus 0 plus 0 once I add all my ones places together. 7 plus 0 is still 7, plus 0 is still 7. So that's how I need to put my 7 in my ones place there. Now I'm adding my tens place together. 7 doesn't have a tens place, so I don't even have to worry about him. 110 has a 1 in the tens place, and 300 is 0. So 1 plus 0 is going to leave us with 1. And now adding my hundreds together. 7's a 1-digit number, doesn't have hundreds. I have 300 and 100 left right here. 3 plus 1 equals 4. Just like with my base 10 model, I got an answer of 417. And finally, for our last 3-digit addition strategy, we're going to do a hundreds, tens, and ones chart. Did I skip a slide? No, I didn't. Just making sure. We're doing our hundreds, tens, and ones chart. I'm going to add together 257 plus 317. This example is going to again be in your packet in section 3. 257 plus 317. I wrote my equation, and now I'm going to write my numbers out to the sides. I'll divide them, and I'm going to make my hundreds, tens, and ones chart. Hundreds, tens, ones. 257 has 2 hundreds, 5 tens, and 7 ones. 317 has 3 hundreds, 1 10, and 7 ones as well. First, I'm going to add my ones together. 7 plus 7 equals, it's a doubles fact, does anybody know it? Maybe it'll play. 14. 5 plus 1 is 6. 2 plus 3 is 5. Now, can I just read my answer and be like, I'm done. It's 560, 14. Nope, we can't do that because 14 does not belong in a single digits place value. So I'm going to need to break that up a little bit more. Again, I'll have to regroup. Since there's more than 9 ones, 4 of those ones get to stay, but 10 of them have to go next door and get regrouped to the tens place. So 6 plus 1, the 4 that we had left went down there. 6 plus 1 equals 7. And we didn't have to regroup the tens place to the hundreds, so we get to leave it as 500s. So altogether, my answer is 570. Numbers, we've now done addition. We need to start doing subtraction as our last few examples. Now, when we subtract, we sometimes do have to regroup. We talked about that with subtracting 2-digit numbers. We need to talk about it with subtracting 3-digit numbers. In subtraction, we regroup when there are not enough ones or when there aren't enough tens to subtract. If there aren't enough tens, you have to go next door and get 100 more. Let's take a look at this example. 346 minus 165. 346 is our greater number, so that's the number we draw in our model. 300, 10, 20, 30, 40, 1, 2, 3, 4, 5, 6. I'm going to start by subtracting at the ones place because it's my base 10 model. So I need to subtract 5 ones. If I'm going to subtract 5 ones, I have 6. 1, 2, 3, 4, 5, 6. If I take away 5, that's going to leave me with 1 left. Now I need to subtract my tens. I have to subtract 6 tens, but I only have 4. 1, 2, 3, 4. So what I have to do is go next door and borrow 100 more. I need to put that 100 over here, and we know that 100 has 10 10 sticks. So once I subtract 6 of those, it's going to leave me with 8. And then I need to subtract 1 of my hundreds. That one's already gone to the tens. I subtract this one, and that leaves me with 100 left. So 346 minus 165 equals 181. If your brain's still feeling a little bit fuzzy, don't worry because we're going to work out some more examples. And just to summarize one more time, regrouping in 3-digit numbers means that you might have to regroup from the tens to the ones or from the hundreds to the tens. Let's do an example where we're subtracting 3-digit numbers using a base 10 model. I'll start how I always do by writing my equation 422 minus 255. And again, I'm going to draw a hundreds, tens, and ones chart because those are 3-digit numbers that have a hundreds place, a tens place, and a ones place. And since it's subtraction, I only need to draw my biggest number, 400, 20, 2 tens, 2 ones. Now I'm going to subtract, and I'm going to start at my ones place because it's a base 10 model. Starting at my ones, I have 2 right there, but I need to take away 5. Can I do that? Nope, I'm going to have to go next door and get 10 more. So that 10 comes over to the ones place. We're going to unbundle him as we regroup. And now we can take away 5. 1, 2, 3, 4, 5. So let's count. We're actually going to go ahead and we're going to think about how we only have 1 10 left right there, but we're supposed to take away 5 away. If I have 1 10, can I take away 5? No. So I'm going to have to go next door. I'm going to have to borrow 100 more, which is 10, 10, 6, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now I can take away 5 10s. I'll go ahead and cross out that first one I had and 4 more. And I need to take away 2 hundreds, so I'll cross out 2 more hundreds. Now let's get my answer. I've got 1, 2, 3, 4, 5, 6, 7 ones left. I have 1, 2, 3, 4, 5, 6 10s left. And I have 100 left. So 422 minus 255 equals 167. Awesome job. We're going to do one more strategy for this last example. It's an open number line, and this time we're going to show adding to subtract. It sounds a little confusing, adding and subtracting together, but watch me do this example and it'll make a lot more sense. I start as I always do, writing my equation to help keep me organized. 422 minus 255. Let me draw that big old open number line. And instead of plotting my biggest number on the right side, since I'm adding to subtract, I'm going to plot my smaller number. And then I'll plot my bigger number, 422. And remember with subtraction, we're trying to find the difference. What's the difference between that bigger number and that smaller number? So I know what my smaller number is, 255. I know what my bigger number is, 422. Now what I need to find out is how many hops I need to take to get to 422 from 255. 255. What do I need to do to get to 422 from there? Well, the first thing I'm going to do is I'm just going to make a 10 and get a little bit closer. If I go just 5 more, I'll get to 260. But am I there at 422 yet? No. So I'm going to have to keep going. I'm going to try to make 100 now. And I know that if I'm starting at 260, I can hop and take a big hop of 40, and that gets me to 300. 260 plus 40 equals 300. But I'm still not at 422 yet. If I go over 100 more, 300 plus 100 equals 400. But I'm still not at 422. So I need to go 22 more, and that would put me at 422. I'm going to add together the amount of all the hops I took. I hopped 100, I hopped 40, I'm getting these by looking at the top right here. I hopped 22, and I hopped 5. So if I add all these numbers together, I'll be able to find the difference between 422 and 255. I'll add my 10s together. 40 plus 22 equals 62, plus 5 plus 100. 62 plus 5 equals 67, and I just brought down that 100 because I haven't added him yet. 100 plus 67 is 167. So we got the same answer that we got from our last slide when we did the base 10 model. 422 minus 255 equals 167. Y'all did an amazing job. I know that that's a lot of work, and I know that that packet is not easy. Anytime you need to access this video, you can pull me up, you can have me work through videos or work through these with you. You can pause me, you can rewind me, you can watch me more than once. And I hope you guys are staying safe and healthy. There are lots of things that you can be doing right now. You can just read a book to your parents, do your summer packet, Read a book to whoever is at home. Read a book out loud to yourself. If you want to practice some math, you can help your parents with cooking. You can help them fold your laundry, count how many pairs of socks you have, and add that to the number of pairs of t-shirts you have. Make sure you're going outside, going on walks, and getting some fresh air every day if you can, and just spending time with people that you love or who you might have at home, and staying safe and healthy is always the best thing to do. So we really miss you guys. I know I miss my kids at Lonsdale. I know all of your teachers across the county miss you. I hope you guys are able to stay safe and healthy, and we're going to come back next year stronger than ever, okay? So go do some homework, go do some math, and we all miss you very much. Bye. Have a great summer.